Our topic is Building with Bamboo, Robust, Resilient, Regenerative, and that's our title. We will have 3 different speakers today, and we're excited to introduce them to you. They all have experience working with bamboo in one way or another, different experiences, and from different parts of the world. And we think it feels like it would be great to bring them together, to have them discuss, to share presentations with us. And then after these presentations, we'll have an opening for anyone to ask questions, an open question and answer session. So I will just introduce, I'll summarize as best as I can the CVs of the 3 speakers, and then I'll hand over to them to speak and not waste any more time. So first we will have Stefan Pollak, and he is a freelance architect and a founding member of Architectura a Kilometro Zero ETS. I might have said it wrong, but he is currently a board member for this organization and responsible for overseas projects in Europe, Africa, and Latin America. He also has experience working on buildings with social utility in Cote d'Ivoire, Niger, Brazil, Guatemala, and has worked on projects in Cote d'Ivoire and Peru as well. He's taught at a number of different institutions across the world. And since 2019, he's also responsible for the sustainable design within New York organization Bacchus, and they promote regeneration for projects in southern Italy. And then I guess just to conclude, his research focuses on collective design methods and construction systems with low environmental impact. And this includes the architectural applications of bamboo and other giant grasses as well as raw earth. So we're happy to have him here today. He will be our first speaker. We will then have Flavia Nabugere, Honorable Flavia. She is a Secretary General of the Uganda Bamboo Association, which was established with the support of Dutch Sino East African Bamboo Program. And this organization she will tell you more about, I'm sure, in her topic. She's also in her presentation, sorry. She also founded Glory Ministries Foundation, which is a faith-based organization that aims to help people come out of poverty. And one of their main activities or events is working with bamboo, helping people to plant bamboo and grow bamboo. She is also a former Minister of State for Environment. That's our second speaker. And thirdly, we'll have Nripal Adhikari, and he is a graduate of the City College of New York. He founded Abari in 2017 in order to reappropriate traditional materials like earth in a contemporary context. With earth, I'm sure he will also tell you a lot more about his practice and what they do. But in the last 5 years, he's worked on various structures across the city and contributed to building a new reputation for Nepal's dying building craft. So I think he has helped, through his buildings, he's helped to show that natural materials like bamboo and earth can be used in urban areas. He's also worked with a number of planters, planting bamboo along the river banks of Chitwan. He also teaches at Kathmandu University and has trained various architects and artisans. So this is his practices. The practice he's founded and works for is called Abari. So that's a very quick summary, and I hope you got all of that. I'll now hand over to Stefan, who will give us the first presentation. You're on mute. Sorry, Stefan.
Sorry, I will. Okay, can you hear me now?
Yeah.
Yes. Yeah. Okay, I was thanking you for the nice introduction and suggesting to pass directly over to the screen presentation. So I will share my screen. Okay. Okay. This first slide is roughly to introduce where I'm connected from. I'm talking from Rome, and what you see in these pictures are a couple of examples of Renaissance architecture. You might ask, where's the link to bamboo architecture, but perhaps we will understand in a few seconds. One hint comes from this map. it shows roughly in darker brown the Mediterranean area. This is where classical architecture of this kind is mostly common originally. Then it spread, of course, but we have an origin of this around the Mediterranean Sea. But actually this map is on something else. It is talking about the botanical diffusion of Arundodonax, which is a giant grass exactly as bamboo is, but of a different type. We will see some pictures in a few seconds, but just to tell you that the origin of this plant is in the Mesopotamic area, so where we have Iraq and Iran nowadays, more or less, and then it spread over to the whole Mediterranean area, and from there to other regions of the earth. So if we talk about vegetable rods and giant grasses, this is one issue. And in our area here in central Italy, this resource has been used for architecture purposes, for example, here as a false ceiling, or it can be used, this is not only true for Italy, but a bit all over the world, as support for wattle and daub structures. You certainly know this method with raw earth. And we did some experiments to use it for other kinds of structures that I will explain better later. So here you can see the rods I'm talking about a bit from closer. This is a little experiment where we did a dome structure with this. But the link to what I was starting from might be found here in the bundles of canes, because this is one of the simplest ways of using this resource, to join it into bundles and to use it as they actually did in Mesopotamic vernacular architecture for construction purpose. So the bundles of cane become the structural elements of the mudif, how this kind of architecture is called. But then an interesting thing happens. If we go a bit further south to Nubian vernacular architecture, we can find architecture built of raw earth. In this case, there are no vegetable elements in the right example. But if you look at it, you see a very close connection of architectural elements that you have from one to the others. It seems to be like a direct transposition of at least the facade design is really very similar from one to another. And we find this this transposition also in this Egyptian temple, for example, where we have those columns made of stone, of course, carved from stone, but recalling the form of bundles of canes. And this brings us also to our classical architecture, where we have columns, and you probably know these columns with the negative niches, and they are said to be the place where canes were relocated in some specific days for celebrations or so. These columns again could host fresh canes just to look like bundle of canes again. So this link is very direct between the vegetable rods, the giant grass that we have as a building material available, and the classical architecture that was then interpreted with other materials like stone in this case. But we also have bamboo here in Italy. This is interesting to show probably. Bamboo is, of course, a tropical plant, so it is not native at our latitudes, but it can grow. As you see, the lighter green, I hope you can distinguish it on the screen. Or better, I should say, the darker green is where bamboo is native, more or less. And but it can grow up to 46 degrees of latitude. So the Italian peninsula is in that, and there are bamboo groves quite over the whole country. Here we come back to Africa. This is bamboo from Côte d'Ivoire, and this is just to show the difference a little bit. We have bamboo in something like 1,600 different species, which also means, of course, different diameters and different strengths. So this here is a bit stronger than the one we have in Europe. We normally don't have more than 80 millimeters. It's already quite an exception to find. The normal is between 50 and 60 millimeters of diameter. Here we can easily find 100 millimeters. And if we go to Colombia or Southeast Asia, we can find much larger bamboo also that can be used for building purpose. According to the dimension of the canes that we use, and here I say canes because it can be the giant reed as the bamboo. We don't need to make differences in that case. We can use it as bundles, as I said, if they're very small. So it makes sense to bundle them, a lot of them together. Or if the cane is strong and big enough, it can be used directly as a building component. The third possibility is to cut the cane in strips. Each of those ways of employing the material is also suggesting a way of building structures, of course. We already saw the columns as bundles of canes, but we can also have bundled arches. I will show you an example. We can, of course, have trusses made of straight or sometimes also of curved whole canes. And we can have, for example, gridshells made of strips. As for the canes, I always like to show this example by Cañaviva. This is an architecture firm from Catalonia. They build structures like this with giant reed. So the Mediterranean cane again. And this is an example of entire canes used within a box truss. This is this solution where you can use 4 parallel canes joined together and held at a distance by other canes from the same kind, let's say. And so this gives quite a strong structural element that can be used as a pillar or horizontally as a beam. The picture you see on the right is from a training session we did in Côte d'Ivoire, where we tried to use the local material because we discovered that there was bamboo available, but it was not used, if not for fences or very simple solutions. So what you also see in this picture, that bamboo is all but straight. Sometimes you find bamboo with very irregular shapes. This is normal because it's a natural material, but this solution of box trusses with joining 4 parallel canes is, for example, one possibility to compensate this irregularity and still have elements that we can consider to be straight in our design. Let's say this little we can force the concept here a little bit. The jointure is made with these wooden elements that pass through, and here, depending on the kind of bamboo, the joint, this is of course a weak point because you need to drill the material, and so this depends on how strong the material is, if it can stay as such or if it needs to be reinforced. But it is a very simple way of connecting the material. This is what we did within an exchange program with European students from the University of Rome that we brought to Côte d'Ivoire to do a building workshop together with local craftspeople. And here you see some pictures where we also employed other techniques like rammed earth walls. And finally, the end product of this experience, of this collaboration, was this small building where you see again we have a bamboo roof made with this triangular beams or this roof structure, and this will then be covered with a straw roof. I have perhaps to mention that the difficulty of this project was that we were ready to start it in February 2020, exactly when COVID-19 appeared. and this made it impossible for us to go to Côte d'Ivoire. So this project has entirely been built by local people, and we just interacted with them like we are doing now with online meetings, and so emails and WhatsApp calls, things like that. But it worked finally. So some small adjustments needed perhaps still, but the building is there and it works. This is just another example from people you might know, because this is a published, quite well-known building. It's the school in Rutrapur by Eike Rosvak and Anna Heringer. And this is just to show a larger possibility of employing straight canes joined together with nodes in order to have performant structural elements. This is the building where this this is an intermediate plane where this is the prototype they are using for the floor slab in this building that is built made of cob, the lower level, and then completely in bamboo at the first level. Just another example from Asia. This is Votrong Nia, Vietnamese architect who uses also these straight columns, entire canes, sorry, not columns, for this roof structure, where we have again this box concept reinterpreted in a slightly more complex way. Or this is Simon Velez, you also might know, from Colombia, who is suggesting since years solutions like that for industrial buildings or very large public buildings. As I said, a third possibility is to cut the canes in strips, and this is something, at least here at our latitudes, we do manually with this splitter, this tool that you see in the photo, which has in this case 5 blades, but according to the diameter of the canes and the size of the strips you want, you can use tools with more or less blades, 4, 6, 10, depends. And one of the first possibilities that you have with strips is just to wave them. It can be a biaxial, very simple waving in 2 directions, so exactly like a fabric. You see this in the central photo. Or a slightly more complex is the 3-axial weaving. This is this particular pattern where you get hexagons and triangles, and actually you can use the triangles to have quite stiff jointures, because you can make the triangle very small, and then the friction between the 3 strips that meet that point is enough to have a quite performant jointure for the whole structure. This is again the biaxial, so the normal weaving. This is an interior design for a cultural center here in Rome, and this was for an interior design in an apartment. But no, here there's some mixture. Sorry for that. This is a little pavilion that we were asked to build for a park in southern Italy, in Sicily. And here you see the 3-axial grid shell. This is the same structure within the villa. So very small pavilion. This is the interior design I was talking about before, within an apartment in Rome again. And so actually this fact of using curved structure something we discovered is that it really makes sense, because you can have quite stiff structures by using apparently weak material, because the bamboo strip as such is not very strong. It's a few millimeters of thickness of material, and it bends really strongly. But if you involve it in more complex structures, it can bring to very performant whole structures. And there are mainly three methods to do that, depending on how much control you want to have on the design. Sometimes it's needed to have exactly a very exact design, because you have constraints of some kind. It can maybe client's desire, maybe constraints of budget. I mean, maybe constraints coming from the context, because there's already something built nearby and you have to refer to it in some way. Things like that can ask for a very controlled geometry. This is one possibility. And the other end, you can have, if you have more freedom, you can in some way have what I like to call indulging geometry, which means that you try to understand what the material wants and to use that. But let me try from the more complex, to start from the more complex one. So here we did a little experiment some 10 years ago, where we wanted a certain shape of a pavilion, of a grid shell. And so we started to draw some representative shapes of this form on the ground. And then we knew about the heights that we wanted. And all of this, very analogical, very manual, and very empirically, led us to have this little structure here that you see on the left, which had actually the form we wanted. We didn't want, because as you saw perhaps before, the pavilions made with the three axial patterns, you are quite constrained in as for the shapes that you can have. They always look a little bit like an egg. They're quite nice shapes. It's nice to stay inside the pavilion like that. But if you want to go further to have other shapes, it's quite difficult. Here we could have this difference because we constrained the nodes directly. It's not a three-axial pattern with the triangles as you saw, but we have bolts going through the nodes. So we drilled the material. But on this, we had then one step further, which is this pavilion, which is visitable in Rome, in the Casa dell'Architettura, is the headquarter of the architect's chamber. And so they have a little garden in front, in the center of Rome, and they decided to install this pavilion, mainly to protect this archaeological area behind, because they wanted people to go quite close to it, but they shouldn't touch it. So this was the solution that we proposed. And so this is a place where you can sit and look at these ruins or just have a rest. And in order to build this shape, which is slightly more complex, we used this approach that we like to call digital bamboo. This is based on a research that I'm leading together with Rossella Siani, a colleague from southern Italy. And based on the fact that we first design the shape and the architecture with the help of a software, and the software gives us a plot of information. What kind of information? The information you see here on this drawing is simply the distance of each internode. So I know that between this joint here and this joint here, I have 40.6 centimeters in that case, and I have this for all the joints, for all the nodes of the structure, and this is something we can translate in what we call an assembly map. So what you see here on the right part of the slide is a representation of the same set of information, means the distance between the nodes and how each node is called, but represented in a bidimensional drawing, just in order to make it easier to print it and to bring it on the building site and to know what we are doing. So from that, the next passages are completely manual. This is something that normally does not happen with digital design. We are used to have digital design processes that feed their information into a machine, and then the machine produces numerically controlled output means by the means of a mill or a laser cutter or whatever. In this case, we do it manually, which is the secret to use natural material, because we didn't solve till now the possibility to feed a machine with a material that is irregular like bamboo is. Each strip of bamboo is different. It has never the same size. The distance between the nodes, where the cane is a little bit harder, is never the same. And so this makes it very difficult to feed it into a machine. So this passage is made manually, but with the help of this assembly map. So the guy or the lady who has to drill the holes knows that the hole G10 has to be at 42.8 centimeters from G11 and so on. So you can have a prefabrication process, prepare all the material, bring it to the building site, and then reassemble it according to this map. This is what we also did in another case where we've been contacted by Tono Mirai, a Japanese architect, who was invited to do an installation for the Biennale in Venezia. And his first idea was to build this kind of structure in raw earth on the terrace of an old palazzo, of an old building in Venice. Of course, the authorities didn't allow that, because they say you can't build such a heavy structure on an ancient terrace. We won't allow, and so he had to find a plan B, and the plan B was doing it with digital bamboo again. And so we tried to design a shape together with Rossella Siani and Antonio Salvatore is another colleague who was involved in this design process. And so the shape was redesigned with this method. And again, we had our assembly map that allowed us to build this installation. Here you also see the place. And yes, this was the fact. If you have a look at the joints, they are made directly with rope, with canvas rope. This was an explicit request by the architect. He wanted to have only natural materials. He didn't even accept the metal bolts that we were used to use in other designs, in other projects. So here you see the final installation. The central cylinder was then covered with an earth plaster, but the external shape is exactly like that. And a smaller little example that we did within a little workshop in Kigali a few months ago with students from a university. It's based on the same idea. So we again have the design made with this software and having all the geometrical information. This picture is just to show you that we can use this software approach also to control other parameters. In this specific case, what we introduced is just something that we wanted to know is the relation between what the material can do in terms of performance and how we can design it. What this drawing is representing is the curvature, the bending radius of each single cane. So we knew from the material which is the critical bending radius, the radius that we couldn't go smaller than that. And so we translated this in, we fed the software with this information, which means that when we change parameters like the height, the central diameter, and just we can stretch this shape as we want while designing, but the software can warn us and saying, hey, pay attention, here is a red zone, here you will have problems with your material, please redesign, more or less, okay? And then again, once the design was concluded, we plot this assembly map, and with this assembly map, we went to the building site, which was here in a tent in front of the Congress Center in Kigali, and with the students from the university, we assembled this little structure in 6 hours, more or less. Okay, but we don't always need, or we don't always have the possibility to use softwares. We can have other approaches, still having induced geometries, meaning approaches where we first design because we need to design it in a certain way, because we have our design constraints, and then we want the material to adapt to that. This can be done. I will show you two possible approaches for that. One is to work on the border conditions. So the example you see here, it's another, it's a shading pavilion in front of a youth hostel in central Italy. And what we decide to do here is to have very strong glulam borders made of timber. They give the direction, more or less. They steer the design, and then we have the bamboo grid that needs to adapt to that. But this was somehow this is somehow freezing the position of the bamboo. Okay, this structure was then covered with a membrane just to make more shadow and also to be protected from rain. The second possibility is the grid shell approach, is where you start from a bidimensional pattern and then you just start lifting points. This works very well when you have those patterns like the triaxial pattern, for example, where the canes can still slide a little bit between one another. Then, because so they can reshape while reaching the final shape that you want. Once you are happy with the shape, then you can freeze this by augmenting the friction because between these strips in some way, or by this can be by squeezing them with some additional bolts, or by tying them with ropes, or in any other way. But you can define the shape while doing it and just inducing the geometry you want, starting from a bidimensional pattern. This is another example where we use the same approach to do the secondary layer of this roof structure. We already had this bent beams that you see in bamboo, and so this layer of triaxial grid was just posed on them, and it adapted to it, but it was woven on the ground, so bidimensionally, before bending. And this brings us to the third possible approach, which is based on the fact that bamboo has a very typical way of bending, which depends, of course, from the fact that bamboo is stronger at its base and then becomes weaker to the top. And this corresponds to a typical bending radius. You see, it's not an arch, but it's a bit closer here at the end and a bit larger at the beginning. But it is something that you can really feel with your hands. If you take this cane and you start bending it, you feel it really what the material wants to be. And this makes it very easy to communicate on the building site. You don't need to have all these complicated things that we had before, to have a myriad of numbers or things to tell to craftsmen. Here in this case, it's just one measure. You say you want this distance to be, let's say, 1 meter or 90 centimeter, whatever, and of course you need the length. But then the rest comes. The exact shape comes from the material. It's the material which determines what it wants to be. So this was the prototype for a roof structure for our little building in Côte d'Ivoire. We then changed this roof because it was not possible to cover. The slope was not strong enough to have a completely natural roof, which we wanted, and so then we passed to the triangular solution that you saw before. But the beam itself was quite strong as a solution, so this can be used as a solution. Again, what does it mean to work with so few information and to have the design led by the material. So this is what I'm calling indulging geometries. Here we are building a dome structure called Domocaña, which is a Peruvian invention that we adapted. And the lady in the center here is just measuring for our curiosity to know how high this arch could be. But actually what you do when you build such a structure is to start bending the canes. Normally the first 3 or 4 crack, you have to throw them away, but then you find the right dimension and you can go ahead and have structures like these, which are really strong. We mounted on that. We got on top of that with 5 people without any cracks and anything. So, and it can have even much more load. This is same issue but made with bamboo strips, while the others made with reed canes. Here you see, okay, this is not the most heaviest person on the world, but you see that it's quite resistant even with these weak strips. And so with that in mind, we did another workshop again in Côte d'Ivoire, where we tried to build such a roof structure with a group of beekeepers, because we were invited to participate in a meeting of this association of environmental activists and beekeepers. And so they asked us to introduce the concept of sustainable architecture, and we decided to build such a roof structure. And again, it proved that it was really easy to make the building concept clear without complicated drawings, without numbers or things like that, just because the material already contains a lot of information on its own behavior, in its own behavior. It's like, I would always say, almost say, bamboo already knows what it wants to be. And so this made it easy to wave this dome, which was then dislocated and brought to a piece of land that this association owns. So here you can see the movement with pickup, and it was brought here on this terrain. Again, in this case, to be used as a shading device, but actually this can be a proposition for a roof in these climates where the bamboo canes are available and can be even more available because the climate is suitable. So we can also think about growing more of it. And it's really involving. This is perhaps the most interesting aspect of this. So it's really, you don't need to have big preparation, previous preparation, because the material really helps to involve all kind of people in this building. Of course, what is not solved in this picture that you see is issues like waterproof layer, or other things that are very important to really be building. This was, in this case, this solution here was used as a false ceiling under an existing roof. So it was not the issue in that case, but this is something where further investigation is probably necessary. And I'm happy to hear from Randy that there's one topic of local talks on tropical roofs. So perhaps I should have a look at this. Probably some answers are already there. Okay, that's it from my part.
Thank you. Thanks very much, Stefan, for that really fascinating presentation. I think we'll just move quickly for the sake of time. I think we want the next presentation to begin. So Flavia, if you can share your screen and turn on your mic. And you have about 20 minutes to speak. If you stay close to time, then we can have some time afterwards for question and answer. Great. Okay.
Yeah, good evening. I am delighted to have been invited to present at this local talks on construction. I'm really quite humbled because I'm speaking after someone who is trained in construction, and I'm just a lay person who is tinkering around with bamboo. That shows you that bamboo is so versatile that you don't have to be schooled in it to be able to use it. My name's Honorable Flavia Nabugere, who is also the Secretary General of Uganda Bamboo Association. I am going to talk about my experience with bamboo. We are talking about bamboo for construction, but because for us we are lay people trying to promote a new product, bamboo, into our community as a poverty reduction elevation entity. So this presentation is about my experiences as a bamboo entrepreneur. It explains why I chose to work in bamboo, why bamboo should be among key cash crops in this country, Uganda, and why bamboo should be building material for the future in this country. A bit about myself is that I'm a social entrepreneur with an Ashok Award, designed for people with innovative solutions to the world's most pressing problems. I founded Lomic Foundation, a faith-based organization with the goal of helping people rise from poverty. So I want to elevate poverty as much as possible. I've also been in the Ministry of Water and Environment as a minister, and I was concerned about rampant cutting of trees for construction as well as for energy. I sought a solution and found it in bamboo, a versatile renewable product. If planted, would have very much needed raw materials, yet maintain a beautiful canopy on the face of the earth. And who is Uganda Bamboo Association? Uganda Bamboo Association is a platform established with support from the International Network of Bamboo and Rattan, and now supported by now it is supported by use for mobilizing communities, individuals, and other stakeholders to plant bamboo. The organization shares information on bamboo resources, bamboo products, technology for bamboo value addition, research, training, networking, and market linkages. The organization that we shortcut as UBA encourages people to plant bamboo and supplies seedlings, offers knowledge on nursery and bamboo plantation establishment and sustainable management. It supplies raw materials such as bamboo poles that can be used for so many purposes. And the Uganda Bamboo Associations members engage with bamboo as farmers, craftsmen, women, youth, managers, employees, and more. As a leader, I have planted bamboo at my home in Kaliro, yet under UBA, we have a nursery and a demonstration landscape that has bamboo of all ages and bamboo products as well as ideas to sensitize new entrants. Moreover, the association offers access to bamboo raw materials. You can see from nursery, from mature bamboo, from young bamboo. We have different types of bamboo. This is giant. This one is yellow. This one is green. They all have different specific names, species names. We encourage people to plant the different types of bamboo, and also we show them what will finally come out when they have planted. Our association also offers exposure to bamboo knowledge and activities locally and internationally, because we have linkages with China, and we have linkages with the Dutch. We have linkages with members in the USA, and it is really quite a global entity, although locally it is operating at a local level. We make structures like furniture, and somehow we are learning how to manipulate bamboo so that we can make better structures. I was looking at the presentation before, and I'm like, when do we get there? Because for us, we are simply at the very stages of trying to see that bamboo can be used for any products that can be marketable. And that does not mean that bamboo has not been used for construction in Uganda. It is there are tribes or areas like in the northeastern areas of Arua and Moyo, they use bamboo for construction. They construct using bamboo in a very local, simple way. And I liked it so much because we have been worried, thinking we really need so much technology. When the architecture, the presenter before, said that the bamboo safe is the one that leads you or guides you on how to manipulate it or how to handle it. And so that is what we are doing. We can train and guide in nursery establishment. We also offer a promise of a market to bamboo farmers. Now, let us, I'm going to talk about bamboo for construction. This bamboo has to be treated to prevent attack by borers. We have had so much experience. As we started using bamboo, we would get disappointed when we find it crumpling into powder. As I looked at the first presenter presenting that final product of the structures, we also tried search only to find that ours would be eaten by borers. So, which shows us that in order to use bamboo for construction, there are other preliminary processes and procedures that you must undertake in order to make sure that whatever you do will survive, that will last. So treatment can be by heating and soaking, or it can be by soaking in some chemicals. We also have the challenge of having the chemicals to be eco-friendly or human-friendly. For instance, if we are going to use the bamboo indoors, then we are worried about whether the chemical used will not be dangerous to the human beings that will be in touch with it. So mostly bamboo for indoors uses salts, boric acid and borax, but the other chemicals for bamboo for outside are necessary. However, if we use the bamboo which has been treated with salts for outside, then again we must put another coat, protective coat, maybe with varnish or some other water retardant treatment, some water retardant solution. Then treatment, as I said, could be by heating. And if you just heat it without soaking it into any chemical solution, again, it can be a little bit difficult. Then we have to understand how old should bamboo be. If we just see it on the building, on the structure, we may not know how old it should be before we can use it. At one time when I started interacting with bamboo, I got so excited about it and I wanted to make a date. So I went out and bought bamboo. And when I brought it to the carpenter, wherever he put the nail, he just tore into strips. And I ended up not making anything out of it. And that is a mistake that happens so often when we get excited about the use of bamboo for either furniture or construction. We go and pick the best looking bamboo, which is straight, which is nice, only to come up with the very young ones, which are good for nothing. So we have those issues in any event of using bamboo for construction. So we try the treatment, and here at my farm, I constructed this facility to be able to soak bamboo into it to make it user-friendly so that it becomes preserved. And then down here, we are using the boiling method. After boiling for 45 minutes, you leave it in the boiler to cool, and then you soak it in this facility. And then in a simple way, this is at our place in the city where we have the demonstration here. It is in the rural area. So we have again to improvise to be able to boil our bamboo in this drum. And what we do is to cut very short ones, and then we turn them round so that we don't have to struggle so much. Once we have treated our bamboo, then we can use it for the different products that you are seeing, and especially for the youth. They use to make furniture. They are learning here to make furniture. They make these lampshades and other desk organizers, some crafts. They make all these as crafts, and also in the same vein, learning to make things like charcoal for energy. So construction using bamboo. Bamboo offers low-cost construction materials. Yeah, when we have tried to use timber cut from these other trees, they turn out to be quite expensive, but bamboo is rather cheap. It is available, it is all over. The only problem is what kind of bamboo, how mature can it be? At Ugandan Bamboo Association, we offer bamboo raw materials which can be used for construction, which can be used for other products like furniture. But we also pile up the useless bamboo, which would be useless, to use it for energy. We offer training in handling bamboo. And also we source skilled builders to use bamboo for construction. And we have to be able to guide them, to advise them that when you are using bamboo, it is not the same way that you use other timber. Yeah, because someone comes in with so much excitement and starts using nails only to find that the bamboo is splitting, only to find that the bamboo is shrinking, only to find that the bamboo that has been used is getting powdery. So we source the skilled ones and we expose them to the use of bamboo and how they can use it, and not with so much technical know-how and not with so much training, but with the experience that we have attained. So we facilitate the training in bamboo construction by lobbying those who know how to train. We are on the program of the Dutch Sino-East African Bamboo Program. So once in a while, we are getting experts coming in who train our people to construct using bamboo. Yeah, sorry a bit. I think I'm having a bit of challenges with the technology. Yeah, so here we can see what we have been able to do with bamboo. First and foremost, we are able to purchase bamboo from farmers. And here we are seeing a truck of bamboo which has come from the farmers, starting to demonstrate the market that we can offer by bringing the bamboo to our site to start working on it. Then here we are at an exhibition whereby we have simply set up the bamboo poles without using either nails or whatever. Just as like the speaker who spoke before me said that bamboo sometimes directs you on what to do. But here we just bought the poles of bamboo, they were fresh, and we simply leaned them against each other, and we had a stretcher. Even the bench these guys are sitting on is also made out of bamboo. Then here we are in the training, construction training with our members and our staff learning to construct. Now here is what we have learned, applying what we have learned. Of course, there was another constructor. This is a little NTC. There was another constructor, and for Ugandan Bamboo Association, we supplied the bamboo and the skilled labor to install the bamboo. Yeah, so bamboo can be used for construction at many levels, for the rural poor and even for the rich. Bamboo can be used to build decent classrooms in disadvantaged schools. In our place here, sometimes you find schools where students are sitting on the floor under a tree. We plan to announce bamboo and to show that bamboo can be used to set up even simple structures. And one of our clients, called Life Shelter International, they have got bamboo from us to build cottages which can be used as schools in refugee camps. Bamboo can be used also to build decent classrooms in disadvantaged schools. Bamboo can be used to build churches and furnish them. As seen above, bamboo serves for cheap but beautiful decorations as well. Besides, bamboo can be eaten. I think you can see these the shoots which are being processed into salad. Yeah, so benefits of bamboo. So apart from construction, bamboo has many uses in environmental protection, in the employment creation, offering food for humans and for animals, that's fodder for animals. It is used in entertainment, it is used in sports, making paper, pulp, timber, and energy products. As we can also see, it can be used for event decorations. And while bamboo is among the future cash crops, bamboo has wide application and can be made in more than 10,000 products, while it has over 40,000 uses. It grows widely, globally in all countries, continents, with just little limitations in Europe. It grows very fast and is ready for use 3.5 to 5 years and is also renewable. Products of bamboo cover all sorts of appliances for domestic, executive, and other uses. The uses of bamboo include, therefore, human food, animal fodder, energy, firewood. That is for energy. You have firewood, charcoal, briquettes, gas, electricity, and other modes. And here at Ugandan Bamboo Association, we demonstrate up to gas. We fire bamboo in a pyrolysis machine to make charcoal, and at the same time to get byproducts like vinegar and tar. Tar is some form of crude oil, which can also be processed by the chemical industry, which we are doing nothing about it. But when we are using bamboo poles to put them in the ground for construction, we rub around the bottom so that it repels insects. And then the same process gives us vinegar, which is used in the cosmetic industry, also medicine. And then gas is the last byproduct here, which is being containerized for cooking. Other uses include the pulp, which is made for clothes, for paper, for furniture, for fresh woods, for crafts, for mats and bicycles. Then bamboo is used in art and entertainment, so landscaping, ecotourism, as well as creating an environment for non-forest products such as honey from bees. It is used in beauty, in health, and in leisure. It is also used in transport, like dashboards for cars, making of bicycles, traders, and even bridges. So finally, when we talk about bamboo for construction, it offers the construction materials for floor tiles, roofing materials, timber, reinforcement materials, and construction support. So it is such a versatile product. That is why we think bamboo is a construction material of the future. Yeah, that's all it is there. The global community has continued to grow, putting such pressure on wood forests, which are cut for timber, energy, settlements, and agriculture. So the consumption of this natural resource far exceeds its regeneration and outmatches any efforts at planting. So bamboo now wants to stand out as something that can come in as a solution. When you look at the tree, it has a very slow rate of growth, maybe maturing everywhere from 6 years to 100 years, as compared to bamboo. Yet harvesting the tree It's total destruction in most cases for most woods. And then it is a labor-intensive exercise, and expenses are incurred if one is going to restore, if one is going to replant. You do total destruction, then you have to plant. And yet with bamboo, we are going to see the case of bamboo. It grows and multiplies very fast. Within 2 to 3 years, a bamboo plant has many shoots that can be harvested individually. Maturity is 3.5 to 5 years. The plant itself, or the forest, can last 50 years to 120 years, beyond the lifespan of most people. When harvested, bamboo produces many new shoots very fast to compensate for what has been harvested. Even after harvest, every part of the pole, the kernel, remains valuable as it can be used to make other products. For instance, as we were working on the energy, we also had twigs, leaves, and other waste that is left over. That one can be used for making the briquettes. Then bamboo has natural regeneration. You don't have to replant. You can use, but you don't have to plant all the time. Once planted, it will be there, it will continue to grow. You keep on cutting, you continue to receive the same product over and over. Each individual kernel is the one you consider when it comes to cutting and utilization. So coming to the conclusion, bamboo is a marketable product having wide application. Hence, it is easily on demand, and its global spread makes it accessible for the global poor, while its beauty and versatility makes it desirable for all classes. Moreover, as a construction material, it is easily replaceable, having the strength of steel. It has the strength of steel, and when properly handled, it will last the 50 years and beyond, even up to 200 years. That is, if properly harvested in maturity, and also if treated properly. Yeah, so thank you very much. That is what I've had to present.
Okay. Thank you, Honorable Flavia, for your presentation. If you could stop sharing screen, we'll just have a final presentation from Nripal Adhikari, and then we'll open for question and answer. So, yeah.
Thank you, Randy. Am I audible?
You're audible.
Okay, great. Thank you for the great presentations before. And it's so good to see things happening in Uganda and in Africa. And I have a lot of soft corner because for Uganda, because I used to work there and I did my first building there, in Kampala. And so I have a lot of fond memories, and I learned a lot from the place and from the people. And actually after Uganda, I went back to Nepal, and I thought I would start my own organization, Abari. which is borrowed from Swahili word. And so today I'm going to talk about vernacular architecture in the context, and like bamboo as the primary material. You see, in Nepal is very much like Uganda in its in the sense that it's got a lot of cultural diversity, and a lot of different languages are spoken in this small country. And economically, we also considered low income countries. So and in many places people are using local resources in different forms. Like, for example, the building on the north here on the top is from the mountains, and then we have in the plains we have things made of thatch or bamboo, and in the mid hills it's made with earth. So basically earth and bamboo is used for about 75% of our building, even today. Like some of these buildings, these are a typical Nepali house. This with wood, bamboo, and bricks. And this picture is particularly from the areas that have a lot of earthquake. Or if you go in the mountains, there are like beautiful stone buildings, with wooden windows. They're reinforced. Mind you, we live in a very earthquake prone area, right? There was just 4 or 5 years back, there was a huge earthquake. So we are in a very critical zone. But these people have been building, our local people have been building a lot of amazing architecture using traditional materials and technology. Or if you look at this same house that I've been documenting, I was documenting for 4 years. Every year there's big monsoon and it gets washed off the paint, and they use natural dyes and wheat paste and they paint it again. So painting and like maintenance is not seen as a problem, but seen as a ritual. Like, so every year they paint it differently. A lot of people come and they paint it. So it's a living tradition, right? Or we have this bridge from 1895, about 100 years ago, or 125 years ago, and it was built with bamboo. Or there were like many these suspension bridges that were made with bamboo and local cane. But unfortunately, we thought these materials were primitive, and so we stopped using them. No, there's nobody in schools would teach about these materials. And so it was kind of like fading away. If you think like somebody would build a bridge like this in 1895, they would build like something like extraordinary with steel. But unfortunately, because we cannot afford to build a lot of bridges with steel, so like people are like crossing rivers with this small metal cable. And like people are literally like risking their lives to cross rivers. uh, and if you just like a simple data, like in the whole country, there's only 17.6% cement. The rest is all wood, mud, bamboo. Um, there's like all these buildings before, or like made with earth or lime or bricks. They are now dismantled to turn it into built with concrete, and it doesn't represent anything special, like a very traditional, or like it doesn't have a unique identity that traditional buildings had. Like if you look at Kathmandu now, a lot of people, when I say I'm from Kathmandu, they have a very romantic vision of the place. I mean, definitely has a lot of rich history. About 10 UNESCO World Heritage Sites are in this location, but because of our poor planning and this crazy fetish for cement, we've turned it into this ugly concrete jungle, right? And why are people doing it? Because there is an illusion that it is modern, it's strong. But as we saw in the last earthquake, at the epicenter, even these big concrete buildings, which is reinforced and known to be to last for hundreds of years, like collapsed like house of cards, while traditional buildings, properly built, did survive the earthquake, So in this context, we wanted to build an organization that would look at traditional architecture and try to put it in modern context, right? So, and one of the primary materials we use was bamboo, because as Honorable Flavia mentioned this in the previous presentation, it has so many versatility, there's versatile uses. And, like it is, just to reiterate, it is one of the fastest growing plants on earth. In Nepal alone, we have 54 species of bamboo, like from tropical bamboo to alpine bamboo. And it's strong as steel in terms of dense intention, but light as bird's bone. Many people actually compare it to steel, but I think it's a wrong comparison. It's much better than steel. Steel is strong, but heavy. But bamboo is strong, but lightweight. You'd rather compare this material to carbon fiber or, very high industrial materials that are used in aircraft engineering or, very high-tech science. And it's earthquake resistant, it's very elastic. If there's a shake, it will bend and wobble and come back to shape, right? And there's nothing in bamboo that is not usable, like from branches to rhizome to leaves. And it's such an amazing material. When it's young, you can eat it as bamboo shoot. And when it's old, you can build houses. And in between, you can make fibers, you can make laminate boards. So it's literally a material that can feed you, that can shelter you, and even provide you with clothing, right? And if you look, it's mostly spread out in the southern hemisphere. We're very lucky to have such an amazing resource at our disposal. Just to give you the anatomy of bamboo, it's long tubes, and these tubes have a lot of sugar modules. One of the reasons bamboo is very strong is because of these tubes, but the reason people don't use it is because in these tubes there are a lot of these sugar modules. So what we need to do when you are treating bamboo, as it was mentioned in the last presentation, one of the major problems of bamboo is treatment. If you don't treat it, it does not last for long, right? So if we wanted to build something, in our countries, building is not, it's a very expensive process, right? So people want to use, they only build if they know it will last for hundreds of years. So when we started this, like the biggest question I always get was, what would you do? Like, how would you make sure that it would last for a long time? So, these are when you zoom into bamboo, you see these sugar modules. So the other problem with bamboo is the sugar content and the irregularity. I don't think that's a problem, but if you talk to engineers, they say it's not a homogeneous material, right? So, and how do you connect? And so we've been experimenting different ways to connect bamboo by acknowledging that it is a heterogeneous material. We did a lot of experiments, and we found this interesting technique where we use metal plate which is slightly bigger than the bamboo, so it can accommodate, you know, any variation of few millimeters. So, you know, so we're not standardizing the bamboo, but we're standardizing the joints, right? So because joints are known to be the weakest link. So, and the other problem, other limitation was its treatment. So, you know, we invented this, you know, we improvise, so to speak, a traditional technique of treating wood and improvised into bamboo treatment. So there is a simple pressurized cylinder where we put preservative and then like lock it. And if you see a bicycle pump, you use this bicycle pump to apply pressure to this tank. And this pressure pushes the preservatives and pushes all the sugar out of the bamboo, right? So, and it works like charm, you know, with once you do it, all the sugar content comes out. You know, all the sugar, the pictures I showed just a few slides before, all these sugar modules start melting out, and then they are replaced slowly by preservatives. So, you know, once these technical questions were solved, I wanted to, you know, build. So, and my concern was to build public structures, you know, like I didn't want to build homes because many people were capable of building their own homes, as I showed in the first slide. You know, they have beautiful homes, but, you know, like modern spaces like schools, hospitals, and community centers, these needed big span, and traditional materials were not doing that in the traditional format. So we used modern engineering with traditional material to build big span structures like you know, this community hall. It's about 10 meters in span, you know, just using local material, nothing fancy, you know, very cheap to build. We built this whole building for less than $10,000, you know, it's just unheard of. It's about 200 square meters, right? It's pretty big. And then, you know, once we built this, confidence level was getting better. And when, you know, we have a lot of very poorly built government schools, you know, they use cement blocks, metal truss, and galvanized sheet, and they are the performance is so bad thermally. You know, if it rains, it makes a lot of sound. If it's hot, it gets very hot. If it's cold, it's too cold. You know, like 3 to 4 months of the year, we have to close school because in these classrooms you can't teach. So, and I'm thinking, like, why don't we use local materials like stones, you know, and bamboo to build primary school? So we built this structure. If you look at the stonework, it's all, you know, hand chiseled, all traditional technique. The stones are using slates, and the trusses are bamboo. We added some skylight, you know, inside, you know, this is earth plaster. There's no cement, there's no stabilization. We just use natural glue. We improvised those drain pipes to make these play spaces. We added beer bottles to have these lights come in. You know, very simple, like a very low budget, and using just local resources. And when we built this, it was very difficult, you know, like in many places in Nepal, it's all mountains. It's very inaccessible by road. You know, we literally have to walk for hours to get to places. And this place was like one of them. So interestingly, after I finished the building, about 3 months later, there was a huge earthquake, This is in 2015. And it was in the news, but this building happened to lie very close to the epicenter, only 12 kilometers from the epicenter of the 2015 earthquake. And nothing happened to this building. And there was a big victory for us, a big vindication that you can build with local material that is strong, that's beautiful, that's inspiring, that's economical. This was a message we wanted to give. And thanks to the earthquake, we were able to put that across. And after that, before that, nobody believed in us, because they were like, oh, these young people, they have good vision, but it is not practical. That's what they were saying. But we proved them otherwise, right? And so we built this proposal for Department of Education. And interestingly enough, I thought we'd have a big battle, to convince them, but they were like, they were so convinced by what we had done previously. They approved this building, and we, this is a traditional U-shaped design, like I explained. So we just modified it, put some open spaces in between, put some skylight, put some insulation, put some natural paint, put some niches, did some rainwater harvesting, all these basic, simple things that can make a big impact. And we, there were so many schools that had to be rebuilt. So, I mean, we didn't have the capacity to go and build all of them. We are a design and build firm, right? Because there's a lot of training involved in this construction. So what we did in that context is we put out open source documents, on our website, on newspaper, so people can just open, like our website and get all these details on how to build the school. And it was, it was copied in many schools. We were pretty happy with how it came out. There's like a different permutation. We live in the mountains, so we don't have big fields like you guys do. So we have to have, small modules and then like do few interpretations. So this is one of the schools. If you look at these bricks, these are locally made earth bricks. These are not burnt bricks. And the roof is, of course, bamboo, we have this open space, like beautiful woven bamboo on top, which diffuses light. We have these reinforcement bands. We usually try to hide that in our private buildings, but for public spaces, they get a kind of security, psychological security when they see this, very spacious, like very, very basic, like very, fundamental, so to speak, right? Here's a different, and this is the inside the classroom. It's the temperature is so cool, like when you sit inside, it feels much better, right, compared to outside. Even the furniture you see here, it's modular, it's made with bamboo, it's lightweight. You can pull and stack one on top of the other. You can write on these benches, you can connect them together. You can make a U shape, you can make an O shape, like so, just using local resources. And here we are teaching women how to make those bricks. It was so simple, and one of the best, like people ask me, what is the cost? And I say, whatever the cost is, it's a good cost because it's going to local people. It's not going to an industry, sorry, it's part of it is cut out, but 54% goes in buying bamboo, making bricks, and 35% in labor. So overall, about 89% of the cost remains locally, right? Only 11% goes to an industry. Like, so more you spend, better it is for the local economy. And we did, you know, like housing for the poor, like using bamboo, rammed earth. And, you know, so that was part of our social project. You know, we just designed one and put the information out so people can copy it. But then we moved on. We were like, okay, as architects, we want to do more interesting stuff. And we got an opportunity to build, you know, one of the libraries, biggest libraries in Kathmandu, our capital, was destroyed by the earthquake. So, you know, they wanted something quick and something that represents Nepal. So we proposed this, you know, like, so we built this huge structure. We wanted to show all the, you know, structural elements of bamboo to give the, and also like people come here, we want to give that theatrical looks, right? And in terms of engineering, it's built in such a way, we use a lot of inspiration from local design. The roof is independent of the walls. So walls are not structural. So in case there's another earthquake, the roof will still be standing, while in the worst case, the walls may crack, or, you know, even the worst case, it may fall. It will, nothing will happen to the roof, you know. So it's, and also it uses the arch concept, and we used a lot of local vernacular typology when we built this, you know, like this, everything here is a local earth, right? We love earth. And here are some of the joints, some of the different setup. This is from outside. So, you know, it gave us a big confidence for us to build. And after this, we were invited to do another school. You know, like people were also confident, you know, like slowly we're changing how people are seeing the material. So this is another school in west of Nepal. It's also in a very hot climate. This is, and so we wanted to design it so that such that there's a lot of openness. There's like a courtyard to it, and also like, you know, we have thick 40 centimeter rammed earth walls to give that thermal mass. We use local clay. We, you know, we don't stabilize with cement. We reinforce it, but we don't stabilize. We reinforce with like 2 bands of 10 mm rod, and then we cap with a concrete band on the top and the bottom, but that's about it. You know, it's just pure good old earth. And then, you know, like a lot of open spaces, you know, like mango trees. We don't have any flowers or anything decorative, you know, these are like vegetable gardens. So the kids can come and like pluck the vegetables and go and get them cooked, you know, sand pits, you know, trying to like these brick, you see these patterns in rammed earth. These are different clay. These are not painted on top. You know, like a bamboo facade on the top floor, so it's lightweight, and while the bottom floor has the thermal mass. This is in between the classrooms. We have this open space. You know, we have this intricate truss that also works as a play space. You know, like, so we encourage the students to climb on it. You know, and these are our happy students there. this is the inside, you know, it's so, the temperature is really, you can really feel the difference. So we're, you know, we're doing more and more stuff, there's more confidence, you know, like this is a house in the city, like just using bamboo furniture, bamboo roof, you know, this is the kitchen, using traditional kitchen, you know, putting some modern plumbing and electricity. So trying to bring both worlds together. Yeah. Here's the attic, you know, like with this bamboo truss. Here's another truss. And so, as I said, we do a lot of public spaces, you know, like, you know, because we believe that you can do something that public needs. It's a social enterprise, right? And also make an enterprise with it. And to end, you know, so these are like what are products. On the end, like we also look at like where we get our materials. So we work with a lot of farmers to plant bamboo, and we plant it in areas that are like, for example, this one. In 2019, there's a flood that brought in, it used to be a beautiful rice field, and there was a flood and it brought in all the sand deposits. And if you look at the left, it's a Google photo. It's all this white is sand, it's all flood. And on the right, you have this lush bamboo forest. This is in a span of 8 years, right? So just to, I'll walk you through. In 2001, this is how the river was. You know, 2005, you know, it's changing its course a little bit. 2010, boom, there was a huge flood, right? It's all the sand deposits. It made like the land so unusable that farmers had to abandon most of the land and go somewhere else. And this is in 4 years, this is what happened. In 8 years, it's become like a vibrant forest. You see all these greens, it's all bamboo, less than. So, and we also do a lot of products, you know. So as I said in the one of the earlier slides, there's nothing in bamboo that's not usable, you know. So the top part we use in bags and to weave, and the bottom part we make bicycle, you know, or houses. So this is how I envision our modern, like a future industry, to be, you know, to take in carbon dioxide and release oxygen, as opposed to the modern industry, which is so extractive and polluting. With this, I'd like to end the slides, my presentation. Here's my details if you guys are interested. Thank you. If you guys are awake, we can take picture.
Very much so. Thank you. Really inspiring presentation, Nurfal. We have about like 20 minutes left, so I just want to open the floor to the attendees to ask any questions. So all the speakers, please do turn on your microphones and audio and camera so that we can see you. And then if you'd like to ask a question, you're welcome to raise your hand or ask in the Q&A box, but please feel free to go ahead. So there we go. Let me just, sorry, I'll just allow. So Joseph Kasimbi, I'm just going to allow you to talk now, ask your question.
Can you hear me?
Hello?
Can you hear me?
Yep.
Okay. Thanks a lot, Randy, and also the presenters for these wonderful presentations. I just have a couple of questions for each of the presenters. With regards to Stefan, I was wondering the projects that you showed in Cote d'Ivoire and Rodrapo, roughly how long does it take to train the local craftsmen on how to work with the material? And also, what's the highest building that you've worked on with bamboo? Then to Honorable Flavia, are there particular species of bamboo in Uganda that thrive well in Kampala's climate? And then to Nripal, Flavia noted bamboo can last 50 to 200 years. However, in your experience, what are the oldest bamboo structures in Nepal? And could you kindly elaborate on some of the maintenance requirements for these structures and the different ways to treat them? Thank you.
Thank you. Shall I start? Okay.
Yes, please.
Yes. Okay. So first of all, I have to precise that the project in Rudrapur is not. I was not directly involved. I put it as an example of possible structures, but the design is by Eike Rosbach and Anna Heringer, two architects from Germany and Austria, who worked in Bangladesh. As for my personal experience, what I wanted to highlight with the final part of my presentation is actually exactly the point that you don't need very much time of training, because some structures can be built, I would almost say spontaneously. If you need very few inputs. Of course, you need a basic knowledge of what construction activity means and how to put material together. But then you can really get a lot of hints directly from the material. This is what I wanted to stress on. And this is, according to my experience, this is applicable to structures of the size we saw. So here, the roof structure in Côte d'Ivoire was a square of 4 by 4 meters, so 16 square meters. And perhaps it would be possible also to go a bit further, to have it a little bit larger. But this is more or less the size where you can apply this kind of approach. Obviously, if you go on higher structures or larger structures, you need more engineering, more detailing, and more constructive solutions, as Nipal also showed very in a very nice way in some of his projects. What else? Okay, this was. Well, actually, the other question was about the height of the buildings. This depends very much on every specific situation you have, because it depends on the need of having a height, first of all. So what we're planning now to do in the same area in Côte d'Ivoire is actually to have 2-story buildings. This is in order to think in terms of densification of the local place, so that there's an urban idea behind. This is something that we are testing at the moment, and hope that we can implement in the next future. But actually, built in this region, this was the highest building that we have with bamboo. So, which does not mean that it couldn't be possible to go higher, but we always start from the simple steps. So it took 3 years from the first example, where we just gathered a bunch of people to see how we can build a simple roof, and then to build a first complete building. This was already a 3 years process. Now we will go to the next step. I will be there probably next January again, and so we can start the next experiences on that level. I hope this answers your question.
Yeah, thanks.
Yeah, thank you so much. Mr. Joseph asked whether there are certain species that do well in Kampala. In Uganda, we have 2 main species, the Highland Bamboo and the Lowland Bamboo. The lowland bamboo is solid in nature, and you find it mostly in the areas of Arua, Moyo, Zombo, those other eastern, is it northwestern in Uganda. Then the Highland bamboo, we find it in the Rwenzori Mountains and Elgon Mountains. Now the Highland bamboo will not grow in Kampala, however much you try. Then the lowland bamboo, it is called Oxtenantera abyssinica. The other one is Sania something. The lowland bamboo will grow in Kampala, but it can also grow in the semi-arid areas. But we have many species that have been introduced, and one of the most versatile and aggressive is called Bambusa vulgaris. It is in two forms, the yellow and the green. And the green is normally referred to as shameless bamboo because it will grow anyway. Whether you get just a small twig and you put it in the ground, it will grow. However, we have also got some support whereby we got seeds from India and from China. We have aspa. Some of it is small aspa, another is big aspa. We have Bambusa polymatha. We have Bambusa longiternode. Then we have the Dendrochalamus giganteus. These ones, as far as I'm concerned, here in Kampala, they are doing well. We planted, we demonstrate what can happen here. There are some that have been given to us as seeds and they have not grown at all. But most of the seeds that have been brought here, they are thriving. Now, our next step will be to test them in Nakasongola, where we have 500 hectares of land where we are planting. We are reserving an area for demonstration to see how the different species will do in Nakasongola as compared to Kampala. I hope that answers your question.
And for me, I think the question was about the maintenance schedule. See, when we design, we try not to expose bamboo to the elements. We try to have a very, the old saying of good hat and good boots. That's what we follow. And so when you do that, you don't really need to maintain much. The only maintenance that you may require, like in any other building, is you paint it every few years, polish it. Yeah, that's it.
Thank you. Thank you for the question, Joseph, and the answers to the speakers. I think we have time probably for one more live question. So I'll just ask Melchizedek, if you want to speak, you can speak. There we go.
Yes, I hope you're getting me.
Yep, we can hear you.
All right. Good evening, everyone. My name is Melchizedek Renatus, a student and one of the youth from Bamboo Concept Center, Uganda. We happen to do projects in bamboo in different areas, but basically my concern was on design. We have our prototype. Our first design we did was for Bamboo Village. This project is found under the website of Bamboo Village Uganda in the October updates, where we designed a community center, and it was under supervision of architecture Robert Van Katz. Now, I was so much interested with the designs of Abari, the gentleman from India. So I wanted to inquire from him, what skills does he involve when he's doing his designs? Like the first presenter shared some of the softwares and the steps you go through designing some of the designs. So I also wanted to know him, what does he involve to come up with such beautiful structures in India? Then my second question goes to Honorable Flavia. We also happen to have some land in Nakasongola. So I was inquiring if we can be able to plant giant bamboo in Nakasongola. Thank you.
First, thank you. First, I'm not from India. I'm from Nepal, which is north of India. So yeah. About no, I think it's about the design. It's it's been a long process. We just look at the traditional uses. We've learned a lot from traditional usage, and traditionally people didn't have the technology that we do, but they were, with whatever they had, they were making the best practices. So we learned certain elements from there and slowly tried to improvise. Like to build that huge structure didn't come overnight. It was an iterative process. We designed something smaller and then like slightly bigger and bigger and bigger. And now, we're doing a monastery that's about 50 meters high, so it's, as I said, it takes a lot of iterations. I hope that answers your question.
Yeah, and then the second question was whether giant bamboo can grow in Nakasongola. Giant bamboo can grow in Nakasongola, but maybe we have planted aspa. There's aspa, and aspa is doing well in Nakasongola, and what we understand with aspa is that it can be a giant. Like I saw one presenter profiled some bamboo, which looks like aspa. Then we have this Dendrocalamus giganteus, which I have here at our station in Busega. We have been struggling to make seedlings out of it, and most of the seedlings would die until we realize that we need to keep that the seedling in the nursery for over a year. Once we have kept it forever over a year, I have planted those seedlings in an area in Ikalido, which is almost like Nakasongola. About last season, about since November, March, and this season, and it is all coming up. Although it takes a little bit longer, but once it establishes, it doesn't easily die.
Okay, thank you for your answer. I'm just going to round up because it's nearly 8. Thank you very much to the three of you, Stefan, Rupal, and Honorable Flavia, for joining us this evening. There are a few questions that people still have to ask, so I think what we'll do is follow up with the questions and then share some answers via newsletter. This session will be recorded. It has been recorded, and we will upload it to our YouTube channel for everyone to be able to watch and share. And thank you to the attendees for joining us. Especially we have a number of people who joined us throughout the year in our other events. So thank you for being present. So yes, we will be in touch, but I think for now that's everything.